actually our 14th episode. And today we're joined by Janakiram and Dawn. So Johnny, he'll be going over some of the top 5 trends we're going to be seeing in cloud native for 2023. So how are you doing today, Johnny? Would you like to introduce yourself? Give us a little background about yourself.
Yes, Mike. Great to be a part of this. I watched some of your previous episodes. So it's fun to be a part of this conversation. So just to introduce myself, my name is Janakiram, Jani, based out of Hyderabad, India. It's past midnight, but I am very excited. I am fully alert. I'm an industry analyst and advisor working with various platform companies, hyperscalers, and I keep an eye on the market trends, understand where it is headed. And currently, my focus is more on edge AI and the convergence of Kubernetes with artificial intelligence and edge computing.
Awesome. Can't wait to hear about what the top 5 trends are. So I'm going to introduce Dawn too. So Dawn is going to be joining us as a new host. She's going to be doing some episodes on her own, but I'd like to introduce her now and kind of joining her to make it a little bit soft landing to come in. So I'd like to introduce Dawn. So would you like to say a couple things about yourself, Dawn?
Yeah, absolutely. Thanks, Mike. So I joined Platform 9 in August on the marketing team. So I head up content on the marketing team side, but I spent about a dozen years working in marketing, but I had more than 18 years or so in tech and tech leadership prior to kind of jumping. I sort of jumped back and forth between marketing and tech, but always on the tech side, always in tech marketing. And I've done a lot of talking at conferences. I've done some podcasts. So when Mike suggested that maybe I help out and co-host a little bit for State of Cloud Native, I jumped at the chance. I was really excited. Mike's done some really great work with the stream, and so just hoping to help make it better. So
Awesome.
we'll just gonna go ahead and jump right in. Johnny, let's kick off today's discussion with just like a high-level look at our topic. I'm sure there's a lot of trends and new and evolved topics in cloud native. So what do you think are the top 5 that we're going to see this year?
Yeah. So the first one that we are seeing a lot of buzz around is platform engineering. It actually kicked off last year. That term didn't exist like the year before, but last year it really caught a lot of attention. It was discussed at KubeCon and then at various other cloud native conferences. So that is one of the top trends that I foresee for 2023. And second thing is the WebAssembly, WASM. And again, it is not new. It's been around for a while, but now it is becoming more and more relevant for cloud native community. So the convergence of Docker, OCI, and WASM with Kubernetes is a very interesting mix. So I see that as one of the key trends. The third one is basically the cloud native edge. So again, edge is not new. It's been around. Hyperscalers have been investing in it. A lot of hybrid is slowly shifting towards edge. But what is interesting is Kubernetes becoming the preferred infrastructure for the edge. So those are like the top 3. And before I go further, I want to save the rest for the discussion as we go along. But I'm just curious. What do you see in the market? Does it resonate? Are these some of the trends that you're seeing as well?
Certainly on our side, I would say that those are accurate. We're also seeing a lot of movement, not nearly as sexy as on the edge or artificial intelligence, but we are seeing a lot of companies that are on-prem that are trying to move to containerization. So we're getting a little bit of that too, that those that weren't born in the cloud are starting to move that way for both operationalization, for cost savings, for those things. So we're seeing some of that as well. Mike, do you have thoughts on
definitely
that?
like the platform engineering part, especially since everyone's probably seen all the posts lately about DevOps is dead, which that'll probably move into like one of the next questions. So I'd say edge and stuff too. I have to hear more about like WebAssembly. Like that's kind of something new that I haven't really seen a lot of. So I can't wait to get to that and hear what that actually is and like how it works. Is it like serverless or something like that? I don't know. All right, so let me go into the question then. So like I said, I've seen a lot of posts saying that DevOps is dead and platform engineering has taken over. So what are your thoughts on that? Is DevOps dead? Is platform engineering the next thing, or they kind of both exist still?
Absolutely. So DevOps is not dead. First of all, you cannot kill something that is not tangible. So DevOps is actually not a product. It is not a tool. It is not. It is not something that can be replaced very quickly. DevOps is more of a methodology. It's a process, and it is more of a culture. That enterprises and large companies adopt. Why large companies, even startups? That is basically a cultural process and a tools-driven mechanism to achieve efficiency in shipping software. So DevOps cannot be killed so fast because it's very young. Number one. Number two, a lot of people still don't understand what DevOps is, and it is not a role where you promote an individual from DevOps to suddenly a platform engineer, because DevOps is a cultural fabric that exists within the company. So it is not a job function. If someone carries this title of DevOps, it's actually funny because it's not a single title or single job function. It is collaborative. It is spread across developers, operations, and across the company. So it is definitely not dead, and you cannot kill it because it is still evolving. Number one. Number two, platform engineering is an evolution or the logical extension of DevOps. But let me step back and tell you what really happens in a large enterprise. First of all, enterprises are turning to multi-cloud. They are investing in AWS, Azure, GCP, and provisioning, configuring cloud resources is becoming increasingly complex. Today, if you look at the number of services that AWS has, the number of services GCP has, and Azure has, they are like 100 plus, and it is becoming overwhelming. And then to interact with these cloud platforms, cloud environments, there are SDKs like Pulumi and CDK by AWS, or even Terraform and so on. So cloud ops is a job function. A cloud ops engineer is responsible for spinning up VMs, for launching a database, managed database, creating storage buckets, and all of that. So that is cloud ops. Then we have a term that I would like to call, maybe you haven't heard this, but cluster ops. Right now, cluster ops is very interesting because it's a job function of a Kubernetes administrator who is provisioning clusters, upgrading them, managing them, configuring the storage, configuring network policies, applying basic security policies. So a cluster ops engineer is responsible for maintaining the cluster health and the overall infrastructure of Kubernetes. Right, exclusively focused on Kubernetes. You call it container ops or cluster ops, but it is basically the Kubernetes administration. So that is the second job function. Then there's a third job function, which is all about DevOps. And again, I'm not contradicting myself, but DevOps is a collective set of tools. For example, using Ansible, Terraform, Jenkins, Docker, a variety of such tools to build a CI/CD pipeline and create a software supply chain. That is all about DevOps. And then you have DevSecOps, where you bring in security and someone is managing the verification of images and validating everything that is going on and securing the supply chain, the software supply chain. So there is DevSecOps. And then there are SREs who are defining the SLOs, SLIs, and SLAs, right? And they are basically responsible for maintaining the uptime of the overall infrastructure applications, and they are looking at some of the metrics that matter the most. And then most recently, we have something called FinOps, right? How do you optimize cost? Should I move to spot VMs on demand, or should we use something like reserved instances in AWS? So how do we optimize cost, and where is the opportunity to reduce the overall infrastructure overhead? So there is FinOps. Now, as you see, a large enterprise is dealing with a lot of ops, starting with cloud ops all the way to FinOps. Now, you have internal developers who are trying to develop and deploy applications. Now, unfortunately, these developers are not immune or not isolated or insulated from the friction and from the challenges that each of these roles deal with. For example, a developer will have to understand cloud ops, will have to understand FinOps. If he's not optimizing the code or the containerization, then the FinOps guys will be upset because it is not optimized for cost. Optimize it for security, DevSecOps. Optimize it for speed, DevOps. So developers are dealing with all these X ops, X star.ops, if you can call it that way. So what do we need? Well, we need a layer above all these ops layers that will make the internal developers more efficient. So you build a new layer that abstracts all the operational functions that I spoke about and exposes what is really needed, what is required by the internal developers of an enterprise, so that they are not dealing with this choice of tools and understanding and reading a lot of documentation, standard operational procedure defined by an enterprise. For example, this enterprise might use Spinnaker as the release tool, but the developer doesn't need to know how to use Spinnaker, because Spinnaker has APIs, and it would make a lot of sense to abstract away all these moving parts and the choices that this company has made into a standard layer. And what do you call that standard layer? Well, it's a platform. So a team that is building the abstraction from all these operational layers and exposing that to the internal developers to make them efficient is basically platform engineering. So they treat platform as a product. And it is not meant for external users or external developers. Remember, just like the IT's first employee, IT's first customer is the employee. The platform engineering team's first customer is the internal developer. They are building for the internal developers. All they are doing is they are reducing the toil, they are reducing the friction that exists among these ops functions that I spoke about, and exposing what makes sense to the developer. So some of the pillars of platform engineering, which include the internal developer portal, where there is a nice GUI or a web interface where I don't have to make choices, but I push a button and I go through the whole supply chain, whole CI/CD pipelines efficiently. Then I have a team that actually treats this platform like a product. So it is called platform as a product, and that is getting a lot of attention. Third one is definitely reducing the toil and making developers more efficient. And finally, developer delight is the most important aspect, whether you are building it for the external developers or internal developers. Platform engineering is all about developer delight. Now, how do you impress the developers who are dealing with all these moving parts and make them more efficient, and ultimately help them ship software faster, develop software faster, and bring all the teams together? So that is where platform engineering comes in. So they are sitting in between the internal developers and the internal ops teams that are dealing with a lot of open source and commercial software, and making it easy so that the choices are already made and exposed to the developers. They can stay focused on shipping software instead of handpicking the best of the breed tools. I hope that makes sense.
Yeah, that was a great answer. It was a lot of information. So you're saying like DevOps isn't dead; it's just had a layer kind of added on top of it that makes it so that like I'm submitting a ticket to my platform engineering team, and then it gets dispersed instead of saying, "Oh, I need to go to DevOps, or I need to go to SREs, or I need to go to this other group." Kind of like that. Okay.
So just one more thing, just to summarize. Sorry to interrupt.
No, go right ahead, please.
So for me, platform engineering is the maturity of DevOps. Once an organization stabilizes their DevOps processes, uses the right set of tools, and they have kind of evolved this and reached a level of maturity, the next logical step is platform engineering. So it is definitely not going to kill, but it is going to enhance the investments made into DevOps.
I got one more question, Dom, for you. So do you think this is happening more with the people that are like on the latest and greatest? They're moving to platform engineering, right? Because a lot of the groups out there are probably still trying to figure out, am I using OpenStack? Am I using VMs? Am I using containers? And they're still on like that part of the journey. This is for people who've kind of figured it out and they're stable and they've moved on to that. So like DevOps is still going to be bigger and maybe more, not legacy, but like you're still going to have everything split in more legacy organizations. Is that how you see it right now, or?
Yeah, so platform engineering doesn't make sense for a small startup, which has a couple of ops guys. It is definitely not meant for them. So platform engineering is more relevant for organizations that are large, that have a lot of internal departments, and a very, very diverse set of architectures and deployment targets and all of that. So that is where platform engineering makes a lot of sense.
Great. Great. Actually, I have a follow-up too. I want to talk a little bit more about platform engineering here in a second, but so you were talking about all the different roles under DevOps and with platform engineering, and about delighting developers. And as a reformed developer myself, you talked about delighting them. And one of the things I know a lot of companies are doing is trying to make cluster development, cluster initiation self-service for developers, so that they're not bugging their DevOps guys all the time to make new clusters for them. Or new nodes for them. They're able to handle all that themselves. That does create a lot of problems for a lot of companies too, where they have sprawl. They have a lot of sprawl, a lot of dead nodes sitting out there, and so forth. Where do you think that, because it affects both the financials, it affects DevSecOps, it affects cluster management. So where do you think the responsibility of that governance falls? Does that fall under one role, or is that sort of a shared responsibility across those DevOps roles?
Excellent question. And this is very close to my heart. So, you know, what you actually explained is the cluster sprawl that actually got initiated. Did I just go blank?
Oh, hold on a second. Your video's gone, but your audio is still
we can still hear you. Yeah.
Okay. I'll go ahead and complete this. Okay. So, cluster sprawl is basically the next generation of VM sprawl. You know, a decade ago, customers dealt with VM sprawl, where it was very easy to push a button and launch a new VM. But today, it's as easy as launching a VM when it comes to launching a Kubernetes cluster. So that is actually not a problem. But then the challenge is IT is losing control over it. IT is getting these shadow clusters lurking everywhere, and they are not compliant, they are not secure, they are not accounted for, they don't show up in the overall governance and the policy management. So the solution for that is the meta control plane, what I call as the meta control plane, because it is managing multiple Kubernetes control planes through one control plane. So what do you call a control plane of control planes? You know, that is the meta control plane. And interestingly, Platform 9's SaaS control plane is actually a meta control plane, which fits the definition really well. Because what it actually does is it gives you a single window to launch any cluster, and everything and anything is going through that. So you have predefined templates, you have predefined policies, you have predefined cluster configurations. So you are basically routing all the requests through a centralized channel with more visibility, control over everything, you know, over performance, compliance, cost, policy, governance, you name it. So that is the reason why meta control plane makes a lot of sense for organizations that are dealing with more than one cluster. The moment you go beyond 5 clusters, it becomes very hard to manage. That's when you need a meta control plane. And interestingly, meta control plane is a subset of the cluster ops that I called. So cluster ops deals with establishing that singular control plane through which the developers can push a button or call an API or execute a CLI to spin up a new cluster. So, you know, that fits into the cluster ops, and that will eventually surface to platform engineering, because if I'm a developer, I log into my internal developer portal, I select the cluster size, I push a button that talks to the cluster ops, and it goes to the meta control plane, and ultimately a cluster gets provisioned either in my data center or in the public cloud, and I don't even have to know about it. Now, that's the beauty of this entire platform engineering sequence of actions.
Awesome. Do you want to give, we can give Johnny a moment if you want. Johnny, I know the cameras might be bothering you. If you want to try, you can. Otherwise, your audio sounds great. We can keep asking questions. It's not a big deal or anything like that.
Yeah. Give me a minute while you guys are talking to each other and keeping the audience engaged. I'll try to fix my camera.
All right. I'll watch for your video come back. I'm going to drop you off for a second. I'll bring you back as soon as the video comes on. All right. All right, Dawn. How's it going? So, I guess everybody watching, we're gonna give Johnny a chance to get his camera working again. I don't know if it might have gotten too warm just from being on for like 40 minutes or so. Maybe it needs to have a different setting updated. So how are you doing, Dawn?
I'm great. I'm really glad to be on the stream. This has been something we've been working on for a while. is having me come on and help. And just so everybody knows, well, we're both working this time. There will be chances where, Mike will be hosting or just I'll be hosting. We may do doubling up again at some point, but this is I think a great opportunity for us to use our different. Mike and I have very different backgrounds. Well, not very different, but different backgrounds, and it really gives us an opportunity to delve in with different audiences. I think in a way that that broadens what we're able to talk about.
Yes, I agree. Especially with your background, it's a little bit more diverse than mine too, like in software development stuff too. I can't wait to hear some stuff about that. All right. So I think you got another question for Johnny.
I do. So kind of on that same topic of platform engineering. So do you think 2023 is like the year of platform engineering? Was there like some sort of flashpoint that made this the year? Or do you think it's kind of like a fallout from things that happened last year? It was last year the year of platform engineering, and now we're just kind of evolving past that?
Yeah. So as I mentioned, platform engineering is a logical evolution of DevOps. Number one. Number two, for some companies, there is a vested interest in pushing the agenda of platform engineering because their tool chain has become so complex and so fragmented that they are asking the customers to build a layer to consume their services. So that is another motivational factor why platform engineering is seeing such kind of push, because the whole simplicity of platform as a service or PaaS has vanished into thin air. Today we don't have that luxury of bring the code, commit the code, push the code, and walk away with a URL. Unfortunately, those days are gone. And today, as a developer, if I want to go live with my code, there are 24 things that I need to do. I have to first write code, package it as a container, and wrap it around a pod, create a PVC, create a config map, create a secret, create an ingress, then finally see the URL. That is the complexity of Kubernetes. And on top of that, we have CRDs and custom extensions and custom layers that are very overwhelming for developers. So, those companies that are actually extending Kubernetes and taking it to a level where it is extremely complex are the ones behind the push of platform engineering, because for their own simplicity, for the sake of simplicity, they are pushing this agenda. Number one. Number two, DevOps is more or less stable. We have arrived at a very stable state of tools and tool chains that are working really well. So we don't need to worry about CI/CD and DevOps and how that functions. So what is the next step? Well, automate DevOps further. Make it more closer to developers. Bring it to a level where the developer doesn't need to see the CI/CD pipeline so transparently or so clearly. Abstract it from the developer and make it look like a push button deployment, and behind the scenes you orchestrate everything. Now that is the other reason why platform engineering is seeing that push.
So it's more than just giving them a Helm chart to fill out variables or different values, right? Like it's going beyond that even.
Absolutely. You have to deal with the Helm chart, you have to deal with customization, you have to deal with some CLIs and kubectl extensions. It doesn't stop with that.
That's funny. Your description is we've come so far from like the Gene Kim Phoenix Project days to where we are now with containerization. Yeah, absolutely. Well, okay, so I'm going to take a left turn here. We're going to talk about some of the other trends that you were talking about. So let's talk about the edge. So what changes do you see for the edge in 2023? And what do you consider cloud native at the edge? I mean, what does that look like?
Absolutely. So first of all, edge is a light hybrid version of infrastructure. So hybrid, is, how do you define hybrid? Hybrid is basically an extension of data center to the cloud. So you have infrastructure running in the data center, but that is connected and managed through the cloud. That becomes the hybrid infrastructure, right? But hybrid is typically a huge data center, with servers and racks and pretty powerful stuff. But when you go to shop floors and manufacturing units and small retail outlets, which are not really connected to the data center, but still need to be connected to the cloud, you need a light compute environment that is giving you just enough power to perform whatever needs to be done at that location. So that is the evolution of edge. It is lightweight hybrid compute, which has intermittent connectivity with the cloud and delivers a unique functionality, a very specific purpose-built functionality for that business. So the key thing here is it's lightweight, but that is an oversimplification. Actually, the edge environment is highly constrained. You don't have the luxury of running virtualization on top of edge, because the edge has at the most 4 cores of CPU, maybe 2 GB of RAM, and an eMMC storage built into it. So you don't have the luxury of running a hypervisor and spinning up VMs and treating it like a virtualization layer. So what do you run? Obviously, the choice is containers. Containers are lightweight. They are a part of Linux infrastructure. You don't need any special software like hypervisor to run containers. And when you run containers, and when you go beyond running 1 or 2 or 3 containers, you need orchestration, and there comes Kubernetes. So Kubernetes is an ideal operating system, if you will, to run and manage the edge. So, containerization, as they call, is the lightweight virtualization, and Kubernetes is the best orchestration engine for containers. So that is what is driving Kubernetes to the edge. And that's what is actually making a lot of inroads into unknown territories like autonomous cars powered by Kubernetes, running in the bonnet, or aircrafts running edge compute powered by Kubernetes. So that is what is the cloud native edge. So an edge computing environment powered by containers and Kubernetes obviously becomes a cloud native edge. So again, that is not a new trend. It's been around for a couple of years, but now there is acceptance, and the enterprises have come to a conclusion that if it is edge, it must be containers and it must be Kubernetes. So it has become a de facto operating system to run edge. And there are a lot of proof points for that. If you look at Microsoft's IoT Edge, it is all containerized. If you look at Greengrass, it is all containers. And many other open source edge related projects from the Linux Foundation, they're all containerized. So that is actually is the main factor driving Kubernetes towards the edge.
So now, like if I'm walking into a Target or something like that, I can almost expect they have something small running a couple of containers somewhere in the store, like that, like maybe Kohl's and like all these other places.
Absolutely. The big case study that comes up very often when we talk about cloud native edge is Chick-fil-A, right? They have documented their best practices of running cloud native edge. They actually have an Intel NUC, the next generation user compute device, which is twice the size of a Raspberry Pi, sitting in every Chick-fil-A, connected to a real science Intel camera, and it is doing a lot of AI inference, and it is running a lot of containers as well. So that's a case study that a lot of people talk about. While I cannot take the brands, I have personally been involved in multiple quick serve restaurant chains deployments and very early prototypes and proof of concepts to run Kubernetes in every store, every restaurant, and every tiny outlet running in a subway or a mall. So there are a lot of chances that you actually end up finding a single node or a 3-node Kubernetes cluster lurking in a retail store, giving them the edge compute capabilities.
So do you think that they're going to hire more engineers for those companies, or are they going to look for platform companies to help them out with that? Like, what do you see with this growing, right? Like, because the market's kind of small for the amount of people that have the expertise in it.
Yes, particularly you cannot imagine a tiny outlet with 3 or 4 employees going and rebooting a machine and fixing kubelet configuration or looking at the observability logs. You cannot expect. in a Subway or in McDonald's or in a Starbucks that is running in a railway station, for example, right? So the beauty of this topology is hardening and stabilizing the edge to an extent that it will start looking like a set-top box. When you deploy a set-top box, you don't worry about the operating system, you don't worry about the firmware, you turn it on, it just works. So that is the ultimate state of cloud native edge, where you bring Kubernetes to an extent that it will power these set-top boxes, and customers or the retailers or the franchisees that are actually running the quick serve restaurant or a coffee shop don't even realize it is running Kubernetes. They treat it like a set-top box, that a telco provider will use to give internet access, or the direct to home cable TV company put something there, right? So it should reach that level. We are not there yet, but that is where the industry is headed. So Kubernetes will become the OS of the set-top box running at the edge, and we need to stabilize and optimize and harden the stack so much that you don't need an engineer to walk in, connect a display SSH and do kubectl get nodes. None of that. It is a set-top box. It will self-heal. If something goes wrong, you dump it, put another set-top box, it will just boot and it will start. That is the ultimate state that we need to reach.
Gotcha. Dawn, do you have any other edge questions before we go to the next topic?
No. Let's head to the edge. I think we could do an entire episode on edge. Absolutely. So
it's like, why aren't you using edge yet? And are you falling behind other competitors? Right? Like that kind of stuff. All right, so let's go ahead and move on to the next topic you're talking about, WebAssembly modules. So what are they? And why are they important now? I've just started hearing about this in the last couple of months, and I'm not really sure what they are.
Yeah. So again, WASM or WebAssembly is not really new. It's been around for a long time. Like most of the technologies, it started from the browser. There are a lot of examples. This is my 27th year in the industry. I have seen a lot of waves, and I can recall a couple of things that actually moved from the browser towards the server side. The first one was Java. Back in 90s, Java started as a browser applet. It was designed to provide rich user interface that HTML fell short of. And then eventually, Java went to the server and it became J2EE, and no one ever ran Java in the browser as applets. It never took off. So the technology has quietly moved from the browser towards the server, and that's where it found its logical destination and the sweet spot. The second example that we have seen of something very similar is the JavaScript. Right? So JavaScript started as a scripting engine within the browser, and then V8, which is one of the most efficient, the faster version of JavaScript engine showed up. It slowly started making its way to the server, and today, Node.js is so popular; it is powering so many server-side projects, server-side deployments. So that is another example. Now, similarly, WebAssembly started as a browser-based project. It is to isolate the browser's code execution from the underlying operating system and enable developers to write something that runs very efficiently within the browser. And because it is independent of the browsers, it is created as a tiny virtual machine. And as long as the developers target this virtual machine, they don't need to worry about running it in Chrome versus Edge, Microsoft Edge, or Mozilla, or anything. So WASM was designed initially for that. But just like its predecessors, Java and JavaScript, WASM also started to break the barriers of browser to move towards the server. Because WASM is ultimately a very efficient, very tiny, isolated, secure virtual machine. So that virtual machine runs a specific set of instructions which are almost like assembly language. That's why it's called WebAssembly. But there is no web anymore. It is now just a very tiny VM that can efficiently execute code. So because it is so efficient and so small and can run the code, it started to feel like containers. The only difference is containers are an integral part of Linux, and it's very easy for you to use the containers in any modern version or distribution of Linux. Wasm does something very similar. It gives you isolation. It runs within the operating system while isolating your code, and can work at a very efficient and high performant mode. So it looks a lot like containers. So suddenly there is a lot of attention on what if we kind of bring best of both worlds. On one side, we have this highly efficient VM, which is the Wasm, and on other side, we have a highly efficient, proven de facto orchestration engine called Kubernetes. Now, what happens if we bring these two together? Can we have Kubernetes manage Wasm binaries just like the way it does with Docker containers? So that is where it all started. And in fact, it's very interesting that Docker has embraced Wasm, WebAssembly, as one of the core plugins and an interoperable layer for Docker. So Docker Inc. is also very excited about Wasm, and they are bringing it much more closer to the container ecosystem. Now, the biggest challenge with WebAssembly is, unlike containers, which promise the developers to write code in any of their favorite language, but package it as a container, WebAssembly is more opinionated and is more restrictive. So, for example, Rust is one of the most preferred languages to target Wasm. Not every developer knows Rust; it is fairly new. For example, if I have invested in Python and if I come from C# or .NET background, Wasm suddenly looks very new to me, and I have to invest in relearning a new language, or actually learning the new language and going through that steep learning curve. So that is where the biggest barrier is. But the ecosystem is building tools or plugins or transpilers that take popular languages like Python and Ruby and even C#, and then target the Wasm runtime. So those bindings and those bridges are coming up, and that will actually make Wasm more accessible. So Microsoft has gone ahead and created something called Crustlet. So Crustlet is a kubelet, that is basically the architecture of Kubernetes, which is running in every node. Now, the Crustlet will let Kubernetes treat a node running Wasm like a typical Kubernetes node. So they have built that layer, which will make Kubernetes treat Wasm like any OCI runtime. So that is a very interesting approach. So what will happen is, we have two parallel technologies now. One is extremely mature, highly adopted, highly popular, and kind of become the de facto, and that is containerization and Kubernetes. On the sidelines, we have WebAssembly becoming more and more popular for its security, for its efficiency, for its compactness, for its speed, and Kubernetes might just become the de facto for the orchestrating Wasm, and then the lines may get blurred, where you can use a lot of your understanding, learning, and investments of containers with Wasm, and still treat Kubernetes as that universal orchestration engine. So that is where the convergence will take place, and that's the reason why there is a lot of excitement.
So is it I just write one thing and it'll run on Windows, Linux, or anything? Like, is that one of the big benefits too?
Yeah, but that's also possible with containers. Microsoft has partnered with Docker, and you can actually run containers on Windows or Linux. So that is not the big promise of Wasm. The promise of Wasm is speed, security, and performance, and the very lightweight and light footprint. So very small footprint. So obviously, Wasm makes a lot of sense to run at the edge. On a Raspberry Pi or an Intel NUC, or a slightly more enhanced microcontroller or a single board computer, Wasm makes the ideal candidate to run your edge compute layer. Now, if you're running edge, remember what I said in the previous discussion, Kubernetes is the operating system of the edge. So you marry Wasm with Kubernetes at the edge, and that becomes a very, very powerful combination, giving you best of both: the lightweight, compact, performant, high-speed runtime, which is Wasm, and Kubernetes that is managing multiple Wasm modules like the way it does with containers.
Awesome. Dawn, do you have any questions on that before I move on to the next topic?
No, again, I think another topic that we could have an entire an entire couple of series of episodes about, for sure.
We'll do that.
Before I move on to the next question, Johnny, what do you think so you said top 5. Those are we've talked about the top 3. What are the next 2? Or the next one? Like, what's number 4, do you think?
Yeah. So I'm very excited about this technology called eBPF. Okay. So what is eBPF? And again, why is the cloud native community so excited about it? And that is basically impacting many technologies of cloud native ecosystem. It is impacting service mesh, it is impacting observability, it is impacting container security. So what is eBPF and why it is turning all these technologies on its head? So first thing, we had a mechanism built into Linux kernel called the Berkeley packet filter. And that was a mechanism to basically enable developers to write tiny plugins that will run inside the kernel. Now, let me step back a little. Linux has an architecture of 2 layers, right? One is called the kernel space, and then the user space. Now, most of the programs run in the user space, and they are isolated from the kernel. They cannot make calls to format the hard disk or to reboot the machine. You got to be a root. You got to have the privileges to do that. So a lot of programs typically run within the user space, and that's the reason why Linux is inherently secure. Then there is kernel, and the kernel is responsible for making various system calls and interfacing with the hardware. Now, if you want to make any change, or if you want to write something that is very specific, that is closer to the hardware or closer to the operating system, you got to be a kernel developer. And being a kernel developer is not easy. It is not meant for faint-hearted. That's a very, very different approach and mindset, and it's a different art altogether. There are very few kernel developers in this world. So writing anything that runs adjacent to the kernel or within the kernel, close to the hardware, close to the operating system, is very hard. So the extended Berkeley packet filters, or eBPF, opened up an opportunity for non-kernel developers to write code that will run inside the kernel. So it is like opening a tiny window within the kernel and telling the developers that, hey, you can write the code as long as your code follows these guidelines, as long as it fits this tiny window that we have opened up for you. So eBPF is a sandbox within the kernel, and developers can write plugins that can be pushed into the sandbox. And because it's a sandbox, there are a lot of checks and bounds that take place before it is actually pushed inside the kernel, checks and balances. So if I'm a developer and I want to really, for example, find out the inbound and outbound traffic of my Linux machine, I got to be at the kernel. But I don't need to be a kernel developer if I know how to write an eBPF plugin. So I'll write a tiny eBPF plugin, and I'll follow all the guidelines. And when I push my code into the eBPF sandbox, there are verifications, validations, checks that make sure I'm not violating any rule. And once my code passes through it, it gets compiled and starts to live within the kernel. But it has a connection back to the user space so that it can report its findings like callbacks to the user space. So I have a component running in the user space. I have a component running in the kernel as a part of the eBPF sandbox. And now I gain visibility and insights into what is going on in my machine. Now, what can happen what power do you get when you are able to tap into eBPF? You can actually do three things. Number one, you have unmatched visibility and control over networking. Basically, you are putting a magnifying glass inside the TCP stack of the operating system and watching every packet that is flowing back and forth within the operating system. That is very powerful. And if you want, you can even block by making a callback and by legitimately asking the operating system to drop certain packets. So you are able to perform network functions that are otherwise confined to kernel developers and kernel development. That is the first thing. Now, what does it translate to? Well, you can write very, very effective, powerful, lightweight network policies. That is the first thing. Second, because you are actually holding a magnifying glass and looking at what is going on within the operating system, you can learn a lot about what the processes are doing and what they are writing to the file system, to the buffer, to the cache, pretty much every activity that takes place within the operating system. Now, if you have 20 containers running in the user space and all of those containers are doing something, by writing an eBPF plugin that sits in the kernel, you can have a watch on all of those. Now, what does that take us to? Observability. Now, observability is typically based on agents, right? If you look at some of the popular approaches adopted by providers like Datadog, Splunk, or any of the popular observability vendors, they push an agent. Now, this agent is responsible for listening and reporting back to the control plane or calling home to tell, hey, this is the new log, this is the new metric, this is the new event, and so on. But now with eBPF, you don't need to have an agent. You can actually have an eBPF plugin that is monitoring the metrics like the CPU consumption, the memory consumption, and so on. It has visibility into every log written by every container running on the operating system. It has access to events raised by Kubernetes and other programs. And it can also do tracing. If there is a call chain, if microservice A is calling B and B is calling C, and you want to find the latency between B and C, you can actually tap into eBPF. Now, suddenly we have the ability of performing observability at the lowest level and gain unmatched visibility and insights into what is going on. So eBPF it is already revolutionizing observability. Third thing is the security. You have the ability to make a callback. For example, when a malicious program is trying to get access, the eBPF plugin will make a callback to a program running in the user space, and it can ask the operating system to say, hey, this looks suspicious, don't run it. So now you just blocked a malware even before it sniffed anything on your system. Now, that is security, right? So first, you are basically exploiting eBPF capabilities to take control of network by creating very efficient firewall rules and network policies. Second, you are basically redefining observability at the lowest level. Third, you are able to get better control of security without a lot of hoops and lot of plumbing, which is otherwise required. So that's the reason why eBPF is so relevant for the cloud native community, and this is influencing, impacting, and forcing the service mesh architecture, which is based on sidecars, to basically use eBPF. We don't need sidecars anymore if we use eBPF, because whatever functionality that the sidecar does for Istio, Linkerd, or any other service mesh is now taken care by the eBPF plugin running at the lowest level. So service mesh is going to be highly impacted by eBPF. Second, as I mentioned, observability. Third thing is security. So when a single component, a single technology is able to handle all these three, by the way, which are critical pillars of cloud native stack, it definitely deserves more attention, more investments, and more integrations. That is exactly what is going to happen in 2023.
And it goes back to the platform engineering team and how they're going to display that to their users, right? Give them insight into
Yeah,
more things.
yes and no. The reason is eBPF is so low level that the developer will never have to know. Uh, and somewhere some SRE will have to figure out what eBPF plugins is going to run and what it really means. But it is far away from the developers line of sight.
Gotcha. All right, Dawn, you got the last topic.
Yeah. So we're talking about we were talking earlier about AI and machine learning at the edge, right? And you talked a little bit about inference at the edge. So how do you see like big data and machine learning combining this year? What are the use cases you see being applied that might not have been a good fit for previous years, especially with some of these trends that you've been talking about over the last hour?
Yeah, great question, great topic. Again, something that I'm very excited about. So, till now, AI has been confined to businesses. AI has been confined to research, and it required a very different skill set and a level of sophistication to consume. But if you notice, towards the end of 2022, everyone has access to AI. It has become democratized thanks to OpenAI and Meta and some of the other companies, Microsoft and so on. And today, if there is one trending topic, irrespective of the domain, that is ChatGPT, right? Everyone is talking about ChatGPT, and every day you see something new, something funny, something interesting, something scary coming out of ChatGPT. Now, that is an example of where AI is heading. It is becoming more and more accessible, it is becoming more and more useful, and it is getting infused into the life of a developer. Today, a Codex or GitHub Copilot is literally helping a developer with pair programming. I write a comment, or I ask ChatGPT, generate a HTML page with CSS that has these colors with these fields. It actually generates the entire HTML plus CSS. It can even do more complex stuff. So that is where AI is reaching. It is empowering almost every persona, whether a developer or a consumer or a copywriter or a publisher. Everyone is suddenly seeing the benefit of AI, and they're also worried. They're also scared because writing a press release, is a big deal, and someone actually spends a few weeks or months to write a press release, and ChatGPT will do that in 2 minutes. That is very scary, right? Now, imagine what would this mean to the infrastructure and the operations world. Well, this term has been around for a while, but now we're going to see the real power of it, and that is called AI Ops. So, what is AI Ops? So, AI Ops brings a lot of predictive capabilities into our lives of administration, operations, and SREs. So, if you look at the sum total of the activities done by the functions that I talked about, like what CloudOps does, what DevOps does, what DevSecOps does. Now, they're all collectively working towards one thing: enable the business to go to market at a faster pace, ship software more often, make it scalable, reliable, secure, and available, right? So all of them are collectively working towards these goals. Now, when you bring AI into this mix, it is going to apply a lot of intelligence at every stage of this. For example, there is a fundamental scaling technology in Kubernetes called horizontal pod auto scale, or vertical pod auto scale. Then we have the node auto scale, right? So when number of pods automatically grow, the nodes also grow when you are in an elastic infrastructure like a hyperscaler, right? But it has been very reactive. If the CPU of a node increases by 75 or breaches 75%, add another node. If the number of pods are consuming X number of CPU cores, spin up another pod, right? These are all if and then conditions. It's like IFTTT sitting inside your cluster. But imagine you bring in an AI model that says, hey, every Friday there is a campaign that is kicked off by this e-commerce company, and when the traffic comes, the number of pods are struggling to serve this. So today it is 4:45 p.m. and by 5 p.m. the campaign will kick off and everyone will get this newsletter or the mailer and they click on this button. So why don't I already spin up these pods and keep them ready? So now that is the job of an SRE who typically does this manually or schedules it. Now an AI model which is learning the heuristics and the context over a period of time is applying that intelligence by itself. Now it is reducing the pain of an SRE by automatically scaling. Now that is a very, very simplistic example, but we can even go further. For example, in the CI/CD pipeline, it's a very common practice to do canary releases and blue-green deployments. Now, what is a canary release? Well, you basically start shipping V2 of your product or software, and you carefully monitor for errors or logs. And if they perform well, you basically add more pods, like you go from 20% of traffic to 30% of traffic, then you go to 40%. And if there are no problems and no errors and no reports from the users, there are no red flags, then you turn it to 50%. And eventually you will hit 100% and suddenly you have V2 available for all the users. Now, what happens if there are errors and the logs are not looking good? Now, someone is carefully monitoring this all the time by looking at the logs, by looking at the patterns, and a team of SREs and DevOps engineers are constantly biting nails to see how this transition works. Now, imagine putting an AI model there that can read the logs and can figure out whether these logs are positive, neutral, or negative, just like sentiment analysis, and can take control of the canary releases by itself. Now the AI model, by looking at the logs, because it has been trained on these logs like ChatGPT, right? So it can figure out that V2 pods have been doing fairly well, so they deserve to be promoted, and it will start doing that. Now, whose job is that today? Well, that is the job of an SRE. Because he is responsible for SLO and SLAs. Now, an AI model is going to do that. Now, in the software supply chain, if there is a malicious or a compromised image that is being pulled from a registry, and there is a vulnerability that is associated, a model that is constantly learning the CVEs and the vulnerabilities available in the public domain figures that the signature of this image matches one of the images that is compromised and shouldn't be a part of the supply chain. It stops the CI/CD then and there. Now, whose job is that? DevSecOps. Now, the most interesting aspect is, starting this year, we'll see more and more of AI coming into ops. And this marriage, this convergence of ops with AI is what is called AI ops. And it is going to impact every stage of DevOps, DevSecOps, SRE, even FinOps. If for example, a workload doesn't need to run on a reserved instance or on-demand instance, it can automatically move it to spot to reduce cost. And that cost analysis is also done by a model. So basically, a model becomes a digital twin of an engineer with a predefined job and a responsibility. So we are going to have models that are called as an SRE model, a DevOps model, a security model, literally reflecting the job function of an individual doing this entire pipeline management. And we are going to have what is called as an ensemble model. Ensemble models are stitching multiple models together to work in tandem. And all of them will find their way into DevOps and will fundamentally change the way operations are run. And that is what is AIOps. And we'll see that becoming more and more prominent starting this year. If we speak about this next year in Jan 2024, I'll still talk about this as a trend, because this is just the beginning, and we'll see very interesting things in the next couple of years.
So the money's in training platform engineering models is what you're telling us. Getting that set up for everybody so they can just start deploying that.
Yeah, a very interesting space.
Yes.
Yeah, it's interesting as you were talking through it. You were talking a little bit about the fear of different people with AIs taking over there, and then you gave the example of changing a web page by telling the AI how you wanted it to look a little bit different. And not to date myself here, I can think back to the days when I wrote HTML by hand in VI. Right. So it's the change is okay. It's going to make your life a lot easier. And that example kind of made me think of a friend of mine works for an organization that always runs Super Bowl ads. And so their SREs would actually be able to enjoy the game instead of worrying about their servers taking the hit from the ads coming in. Yeah.
But Dawn, this is not something that is forward looking. I'll tell you something very interesting that I experimented just yesterday. I went to ChatGPT and said, hey, can you help me create a Docker file for Python? So it literally typed away the entire Docker file that contains an Alpine image of Python. And all I had to do is copy paste. And it also told me that, I need to run a command to package this into a container. So I ran that, right? So my first step is done. I built a Docker image. Then I said, hey, I want to push this to quay.io. Then it actually gave me the command to push it to the container registry. Now, then I said, okay, I have this container image. Please help me generate a YAML manifest to package this as a pod. And then it generated a complete pod spec and also asked if I need a service to expose it. And it actually gave me an all-in-one YAML that packaged my container as a pod, actually as a deployment. It exposed it as a node port service. And it also told me to do a kubectl apply on it. Now, that is a big step. So I came so close to deploying it. Then I said, okay, now I want to automate. Please help me create a Jenkins file to push this into a CI/CD pipeline. Then it created a Jenkins definition, which I would have handwritten the entire thing. And then it gave me a Jenkins file. Then finally I said, give me a Terraform definition to spin up an EC2 instance. And it gave me that. And finally, I could literally connect all these things together. And what would have taken a few hours got reduced to a few minutes. And I went from packaging a container to deploying it in the cloud in less than 7 minutes. Very scary.
Crazy. That's like replaced your search engine completely and reading tutorials and all this other stuff that people create content for. That's amazing. It's scary too, because it could be someone that doesn't really know what they're doing. They do that and they get something running and then it breaks. And how do they fix it?
It is scary because it is replacing a Kubernetes engineer. It's actually replacing a certified Kubernetes administrator.
Awesome.
I bet you many of them have enough to do that they'd be happy to offload some of that work to someone to ChatGPT or somebody else.
So I know it's getting late there, Johnny. I think we've hit time too a little bit over. Everything was super interesting. I think we'll have to have you on again soon so that we can talk about this in more detail. But
absolutely,
I guess I'll go ahead and, unless you got anything else to say or anything else you want to add, I can go ahead and close out here, or we can.
Yeah, I just want to wrap up because we discussed a lot. So I want to just wrap up the conversation by calling out the 5 things that we discussed. The first thing that we discussed was all about what was the first topic? I just lost track of it.
It was platform engineering.
Platform engineering. How can I miss that? Okay. So we spent a significant amount of time on platform engineering. Then we spoke about Edge, the relevance of Kubernetes at Edge and how it's going to increase and impact this year. Then we spoke about WASM. Then we spoke about eBPF, the 4th trend, and finally AIOps. So those are the 5 things. And by the way, these are not the trends for 2023. Many of them, at least 3 of 5 that we discussed, will continue to be the themes for 2024, 2025, and further. So this is just the beginning.
Awesome. Dawn, do you want to say anything else before I do the outro and say goodbye?
No, this was great, Johnny. Thank you so much
Yeah.
for joining us, and Mike, thank you for letting me come in and
Yeah.
crash your party.
And thank you both. So thank you both for joining us. It was very interesting. It's a lot of information, so we'll have to hopefully like rewatch and share. And like I said, if you missed anything, you can watch a replay on LinkedIn and YouTube, and then I'm gonna also post this to Spotify, so you'll be able to find it on all your podcast things. So I think we're good. It's just so much information now. I'm like overloaded and trying to think about it. Thank you so much again, Johnny. Thank you, Dawn.
You
I guess we'll
bet.
go ahead
Thanks,
and end there.
everybody.
We'll see everybody next week. All right.